the last lecture, we have looked at how to use brittle coating technique in conjunction with strain gauge technique for large scale problems. Now, we move on to the next technique, holography, and this is very similar to, the name is very similar to photography. But what is holography? Holography tries to provide you complete information. When you say complete information, what complete information? It tries to give you intensity and the phase information. So, we need to understand little more when we come to holography, and the phase information is recorded as interference fringes. And before we get into some of these details, we will just see lasers are used in holography. We will just look at what do we do in conventional photography, and we will look at what is that we do in conventional photography. And I have the figure of photograph of Athena, Greek goddess of wisdom, because I want all engineers to be wise. Acquiring knowledge is not sufficient to be a good engineer, you need to have practical experience. Knowledge combined with practical experience constitute wisdom. Okay. So, what you see here is you have a beautiful picture of Athena, its illumination is white light. Suppose I change the light source, what happens? This figure is much better, this figure is not even nice to watch. And what you find here is you can see very clearly there are specular information, that is, you see dots, red dots lying on that, and this is what happens with any laser illumination. When you illuminate anything with laser is highly monochromatic and highly coherent, but you have this information available only in this fashion, and this is your positive. Okay. Now, let us look at what is a negative. When I have a positive, when I have a negative, if I look at the negative, I can make out what does this negative contain. You see intensity is recorded. When you have black in the original, negativity is white. So, it allows more light, and then you get that as a black in positive. So, in conventional photography, you are able to clearly see that I record intensity, and then you are able to see intensity variation, and you are able to look at this is positive and then conjecture what a negative could be, or from negative you could see what is the positive I have recorded. So, this is the information I want you to recognize from conventional photography. Now, we go back and then find out what holography is all about. So, in holography what I find is I record both intensity and the phase information, and now you have to know what is phase. Okay, what is phase you need to understand. I have a deflected object here, I have a light impinges on it and it reaches the model, and I would like you to have a fairly neat sketch of this, because this gives you in nutshell an understanding of what is phase. I have shown a deformed object and I have a laser source which hits the object, the depth is different. So, when the light scattered from this reaches the screen, it reaches at different values of phase. So, the phase carries the depth information. So, in normal photography you do not record the phase information, you record only intensity, that is what we have seen, the positive and negative. The moment you come to holography, you record in addition to intensity the phase information of the reflected wavefront. So, that makes holography different. how this phase information is recorded. Its phase information is recorded based on principles of interferometry. And what we will see is, we will see the ideas listed here. So, what we do in holography, it is a process of recording and reconstructing the complete optical wavefront reflected from an object. When I say complete optical wavefront, I said intensity as well as phase, and we have seen in conventional photography one records only the intense information of the wavefront. In holography, phase of the wavefront is also recorded, and phase of the wavefront is recorded by employing the principles of interferometry. Okay. So, that is a difference, and we will go back and see how does a hologram look like, and then what do you see in that. I have a hologram here, and what is the important point here is, first observation is the image is not good as what I record in normal white light, but because I record the phase information, when the observation point is moved horizontally, different perspective of the object is seen. So, you are able to get the 3-dimensional effect of the recording, as if the model is in front of you, you are able to go peep what it is, you are able to see that. I will show you that in my animation. Okay, I will also magnify this, I will show you this, and this was hologram was recorded in the lab of Professor Kothiyal and Dr. Krishna Mohan at Applied Optics Lab, IIT Madras. And now I move my head, and what you see here, I see objects behind, I see this swan is behind, and you have a statue of Lord Ganesha in the front, and then I move it to the right, then you are able to see the depth information. Are you able to see the depth information? As if the objects are kept before you, you are able to see the depth information, you are able to get different perspective. This is recorded as if you are moving the head over the region of the hologram. But from our measurement point of view, we are not looking at only 3-dimensional pictures. Our interest is to go in for deformation. In metrology application, this is useful. Are you able to see the depth information? Are you convinced that holography records depth? Okay. Now, we go back and then see the other aspects of it. So, what I find is, the recording medium should have a high resolution to record this information, because I am recording both the information of intensity and phase. So, I need to have a high resolution to record the information, and holography is also called as lensless photography, and we have to see further what is the implication of the use of lensless photography and how it is recorded. And traditionally they were having a very high resolution, they had holographic plates, that is how they are able to record the holograms. See, in the case of conventional photography, the holographic record of the object will have no resemblance to the original image, but only densely packed interferometric fringes. This is my interest to show, because in the case of conventional photography, you look at the negative, you are able to make out what is recorded on that. Suppose somebody gives you a hologram, you will not know what is that unless you reconstruct it. Okay, this is the fundamental difference. So, what you see here is the hologram needs to be reconstructed to view the 3-dimensional object, and for the set of Ganesha and swan, what is kept, if you look at the hologram is like this. We will see that enlarged, and this is what I see. Do you make out anything here? You see only some funny fringes on this. So, this contains information of swan, Lord Ganesha kept at different distances, you are able to peep into it and then you are able to see that. So, by looking at the hologram with a naked eye, you cannot see the picture, you need to reconstruct it, you need an optical arrangement to do that. Okay. And that optical arrangement is shown next, and this is what you see here, and what you have here is I have the hologram mounted, I have a play of laser which falls on this, and you will have to look at this hologram and then record the 3-dimensional depth of the hologram. So, it is not like conventional photography. Conventional photography, you have a digital camera now, you take a photograph, instantly you see what you have recorded, but in holography you will have to reconstruct the hologram and view it. But many will disagree with me, sir, we are seeing hologram day in and day out in many of our simple appliances. When I buy a cassette, I have a hologram printed on this. What is this hologram? Though it is not needed for your stress analysis or the strain displacement analysis, it is better to know, have a common knowledge on what are these holograms. Okay. That is what we have seen, reconstruct hologram gives a nice 3-dimensional view. Now, what we want to see is recording the hologram is a sensitive and involved process. Okay. It is not a, that is why it is used for security devices. However, the reconstruction is fairly simple, though for reconstruction I need an optical arrangement to do it. So, this has made holography attractive for addressing security issues, as it is difficult to copy. That is why people use hologram stickers. Though for measurement purposes one uses a laser for reconstruction, with advancements in technology it has been possible to construct holograms that could be reconstructed using white light. So, what you see as holographic stickers are nothing but white light holograms. There is some sacrifice of quality in the process, but at the same time, because holograms are difficult to make, duplication is difficult. So, you are able to give a guarantee to the genuineness of the product if you see the hologram given by the manufacturer, and these holograms are named as rainbow holograms. Why they are called as rainbow holograms? There is a reason behind it. Many times you do not know how to even look at the hologram, how to look for information, and we will see what are these rainbow holograms. And what you have here is these are made by double holographic process. An ordinary transmission hologram is used as the object, and a second hologram is made through a slit. It is an optical requirement, and the focus here is I want to see the reconstruction without going into complicated optics, just normal white light should be good enough. That is the purpose behind it. So, what you have here is the slit process removes the coherence requirement or the viewing light, and hence the 3-dimensional object could be viewed with white light. So, there is advantage. So, one of the greatest application of holography is in security, which you see it has become so commonplace. Almost anything you buy, it comes with a hologram sticker. And if you go back in history, it was in 1983 first the Visa card, the Dove hologram was used. I will just show you that. So, what you have here is you have a Visa card Dove hologram. This is a Dove, and you could even see the color change. And what we will do is we will look at another hologram which was also released during the same time, how to view a rainbow hologram. What is the difference between a conventional hologram and this? This is more from a point of view of appreciating how your holography is used in various applications. So, what you find here is I have a beautiful hologram here, and we will have a magnification of this and then see the demo. And what you have here is, if I move my head horizontally, I will repeat it again, you could see beautifully the 3-dimensional depth of the eagle. Could you see that? I will repeat it again. You are able to see this, and this hologram was recorded by Haynes of ID Tech Images. It was done in 1983, and this was published on the National Geographic Journal as a cover page. They were popularizing holograms at that time, and what you saw here as animation, it requires skillful photography to reveal and assemble them together. See, in the normal books, what they will show is, they will show one extreme view, one middle view, and one another view to show that it is recording the depth information. And this was done by Guru Prasad, who had done it at IIT Madras, and these are assembled to give you a nice 3-dimensional view, but still it does not explain why it is rainbow hologram. So, you have a horizontal slit limits the vertical perspective of the original hologram, and the rainbow hologram retains the 3-dimensional character only when the eyes are moved horizontally. When I move my eyes horizontally, I have a 3-dimensional representation. If I move the eyes vertically, I would not have a 3-dimensional representation. I would have only rainbow of colors, and here again recording is difficult. Its recording is very difficult, and that was done by my student, and that is what you will see here. You will see beautifully the play of colors. So, I have this on the vertical movement. When I do it, I have play of colors, and this is what you see. You could see the whole eagle as green. I will move further. You could see the whole eagle as red, and this is this is because of the aberrations. If the illumination is not all right, you do not see this comfortably. And so, what you see here is, you are able to see different colors of the rainbow. I am able to stop only at green. I want to stop it at blue. Let me see one more. Okay, I am able to stop only at, my reflexes are such, I am able to stop only at red or blue. Okay, I will also want to stop it at blue. Okay, no, I will stop it at blue. I will try one more time. No, I am unable to do that so fast. So, what you find here is, you have a nice hologram, what you have the rainbow of colors, and here, because the images are not assembled properly, you say a semblance of depth, but it is not actual depth. What you saw in the earlier one, when you move the head horizontally, you saw a beautiful depth. Here you see only colors are different. Okay, that is why it is called a rainbow hologram, and these holograms are commonly formed as surface relief patterns on a plastic film, and they incorporate a reflective aluminum coating, which provides the light from behind to reconstruct the image. So, what we saw in conventional holography was, you need to have a laser arrangement to view the hologram. You cannot view the hologram like reading a normal negative. You need an optical arrangement to do that, but people found, as advancements developed, they could do away with reconstruction optics. Normal white light can do it, but in the process your 3-dimensionality on both directions is lost. On one direction you are able to preserve 3-dimensionality, on other direction you see only a play of colors. That is interesting, that is very interesting. So, you have a play of colors, and that is a way you have to verify whether it is a genuine hologram or not. And these days, they have multi-layered holograms. You will see on one layer one information, another layer another information, and this use of holography is more from security point of view, less from stress analysis point of view. So, what we will do is we will try to look at what is the use of stress analysis in the next class, and you will also have to remember holography was invented in 1948, as recent as 1948, and the person who developed holography or invented holography was given a Nobel Prize for it. So, it is a invention of that fundamental in nature that he got a Nobel Prize. It is Dennis Gaber who got the Nobel Prize in 1971, and this holography finds numerous applications, but we will focus our attention from solid mechanics point of view. How do I find out the displacement? Primarily it gives you displacement. I spend little time on rainbow holograms because that is what you have access to easily, and you should know, at least go and educate your people at home how to view an hologram. So, if you have a rainbow hologram on horizontal direction, you will have a 3-dimensional representation. On the vertical scale you will see play of colors, but now you have layered holograms. So many varieties have come, so many varieties, even there they have used color, try to bring holography in color. There are so many developments. So, those are all like more from marketing point of view, displays, and then public use of holography for fun. We will not get into all that. We will only look at how holography can be exploited for stress analysis. In this lecture, we have looked at the fundamental difference between normal photography and holography. In normal photography, we record only intensity information, whereas in holography we record both intensity as well as phase information. We have also looked at holography using white light. These are rainbow holograms, and their applications for security purpose are highlighted. Thank you.